In this tutorial, we will talk about ammonia and methane, NH3 and CH4. Volcanoes also produced nitrogen gas and N2 gas, which gradually built up in the early atmosphere. And there may have also been smaller proportions of methane and ammonia gases. Actually, any methane and ammonia found in the Earth's early atmosphere reacted with the oxygen. Oxygen was formed by plants doing photosynthesis. So methane, CH4, will react with oxygen, O2, to produce carbon dioxide, CO2, and 2H2O, water vapor. On the other hand, ammonia and H3 can react with oxygen, O2, to produce nitrogen gas, N2, and water vapor as well. So this means that as the levels of oxygen gas increased, oxygen was able to react with methane and ammonia to produce carbon dioxide, nitrogen, and water vapor. So this removed the methane and ammonia from the early atmosphere. On the other hand, the levels of nitrogen gas, N2, in the atmosphere could build up as nitrogen is a very unreactive gas. So we know that the early atmosphere contained nitrogen gas, methane, and ammonia gases coming all from volcanoes. However, as the level of oxygen gas increased in the atmosphere, remember that oxygen gas came from photosynthesis of plants. So oxygen gas reacted with methane to produce carbon dioxide, and it reacted with ammonia to produce nitrogen gas. So methane and ammonia were removed from the atmosphere, and the levels of nitrogen gas built up in the atmosphere because nitrogen gas is very unreactive gas. Over the past 200 million years ago, the proportions of gases in the Earth's atmosphere had stabilized, and they are much the same as they are today. So the atmosphere today contains nitrogen, oxygen, some argon, carbon dioxide, and trace amounts of other gases. Actually, around 78% of the atmosphere today is nitrogen gas, N2. 21% is oxygen gas. The percentage of argon is 0.9%, and that of carbon dioxide is 0.04%. So the atmosphere today is mainly made of nitrogen and oxygen gas. The noble gases are all found in air. Argon is the most abundant at about 0.9%. We have also neon, krypton, and xenon, and all of these, neon, krypton, and xenon, make up less than 0.1% of clean dry air. So this is the composition of the atmosphere today.